So hello everyone and welcome to Programmatic Brains. So today the question which we're gonna do is sum of distances in a tree, which is today's lead code daily question. So we have been given a graph or rather a 2D matrix edges, and there we have been given where each edge is given to us, like every AFI and BFI, that is every row suggests that there is an edge between them. So let's see an example over here. The example is given as such. So here edges 2D matrix is given to us. So 0 comma 1 suggests that there is an edge between 0 and 1. So what you have to return in the answer? So you have to return the sum. Basically you have to return an array called answer or of any name of length n, where answer of I is the sum of the distances between ith node in the tree and all the other nodes. So here, as you can see, we have returned an 1D array. So we have six elements, which is equivalent to n equal to 6. So we have six answers for this. So what each answer is denotes. So for I equal to 0, that is node equal to 0, we returned 8. So 8 is basically the sum of the distances between the node 0 and all the other elements, all the other nodes. So as you can see, let's see. So the distance between 0 and 1 is 1. Distance between 0 and 2 is 1. Distance between 0 and 3 is 2. Similarly, distance between 0 and 4 and 0 and 5 is also 2. So if you sum it all, so 1 plus 1 plus 2 plus 2 plus 2 gives us 8. Similarly, we have to do it for node 1, node 2 till node n minus 1. So we do this and we have to return this sum, this array. So basically what I've done is this is basically a graph question, although it has been named as a tree question. So what I do is that I have declared a graph or rather a map, which will basically represent the edges in the form of a graph. Second is a DP hash map, which I will explain you further. So first thing first, I will convert this edges 2D matrix into a graph. So I have done that thing over here. And then the next thing what I have done is that I have created a new answer array, 1D array, which will be our answer. So for each I equal to 0 to I less than n, that is for every index of the array, I will be calling the DFS matrix. And the main thing which you should know is that although we are not considering any one node as the parent over here, for each and every I will be considering that matrix, that node as a source, that is that node as the parent or as the starting node. So each and every node will get a chance to be the source node, that is the starting node. And then I will get a 1D array again, and then what I will store in the answer array is basically current of 0, that is the first element minus the second element of that array which we got. So this is the DFS matrix. So basically what it accepts in the as the parameter is simple. It accepts the source, which is currently I over here. Parent, currently initially the parent of each source will be -1. Next is a scene hash set, just to make sure that we don't again visit the same element node in that occurrence. So note that this scene hash set is separate for each and every iteration, like it is not a single, it is not common for all. So if for I equal to 0, 2 is visited. So if now for the next iteration, that is I equal to 1, that again that node will be unvisited, so it will be again has to be visited. So make sure that, because we have supplied a new hash set. Second one is a map graph, that is graph we just created over here. And the last one is basically a DP hash map, which we will see how it will work. So what I have done is that I have simply first thing first, I will add the whatever source I have to the scene matrix or the scene hash map or hash set. Then if the DP contains that element, the key related to the string, that is a key. So first of all I will create a key of which will be a string, and it will be of type parent @source. So I will explain you how it works. So next what I will do is I will get the list associated with that source. So like for 0 I have the source, I have the list will contain 1 and 2 because it is connected to that, so I will get that. Next I will have two elements, that variables, that is count and sum. So count will be initially 1 and sum will be equal to 0. Sum is basically the sum of the you I will explain you further, and count is basically the number of nodes through it. Next, what I will do is I will use depth first search technique in this, and for each list.getI, if it is not in already in the scene hash map or hash set, so I will call the DFS and make that as a source, and now the parent will be the current source. So I will get an array from that, and I will sum plus equal to simply sum will be equal to sum plus the first element of the array which we got, and count will be equal to second element plus. Then at the end what we will do is we will plus add the sum, we will add the count to the sum, and we will return this. But before returning we will just store that into DP for that key so that we can again use it. So now let's move to the how it actually works. So basically what I've done is that I have used this a simple graph. So this a simple tree I have used as an example. Then what I've done is that I've, as I said you, I've created a map for it. So for 0 we have array list. This is the map which we created. Okay. So for 0 we have 1 and 2 because it is connected to 1 and 2. For 1 we have only 0, and for 2 for 0 3. For 3 we have only 2. So now next, as I said, we will be creating an answer 1D array list which will be our final answer. So let me copy my code and I will explain to you. So I've copied the entire code over here. So let's see this and iterate through it. For I equal to 0, I will call the DFS matrix with source equal to, source will be 0, and now parent will be -1 initially. So parent is -1. And of course we have the scene matrix, a scene hash set over here. So first thing first, I will add this source to scene. So okay, 0 will be added. Next is now DP. Now okay, we will have a DP over here, so that if we have the already answer we have for that key, so we will return it. But currently the DP is empty, so I will move to the next one. Now what I will do is that I will I will iterate through the list associated with that source. So the list associated with that source is basically 1 and 2. As you can see with for source 0 we have a 1 and 2. So now also count is equal to 0, count is equal to 1, and sum is equal to 0. Okay. So the next thing is that now if the scene list now I will iterate through the list. So now the first element I get is 1. Okay, so I get 1. So for 1 it is not in the scene. Okay, so I will now call the DFS function. I will call another DFS function with source equal to 1. Now source will become 1, source will become 1, and now parent, now my parent won't be -1 now. The parent will be 0 because it was called from the 0. As you can see, it was called from the 0th node. So this was the source. So now this became a parent, and now source is 1. Okay. So now here again I will add that to scene. So again here is the scene, I have added it. So make sure point to be noted is that it is common for all the like for the entire traversal it is common scene. Okay, it is not for only 0th node or only this node. It is common for the answer I equal to 0. So okay, now I have this. So again count is equal to 1 is 1, and so sum will be equal to 0. Now next one, now we take the list associated with 1. So the list associated with 1, so the list associated with 1 has only a 0 with it. As you can see over here, this it has only 0. Now 0 is already in the scene, and we have also have a condition over here. If it is not in the scene, then only we will call the DFS function, but it is already there, so we won't be calling any DFS function further for source equal to 1. And what we will do is that we will now add sum plus equal to count. That is sum is equal to sum plus count. So now sum was 0 and count was 1, so sum became sum plus count, that is 0 plus 1, that is 1. Sum we have as 1, and now we will return this this sum and count. So we will return sum comma count, both are 1 1. So we will return it to node 0. But before returning it, let's just store the key. So I forgot about the key. So basically here the key for the node source equal to 0 and parent equal to -1 will be parent at the rate source. So parent is -1 at the rate, or you can take any character at the rate source. Okay, it was minus at the rate source, and for this it was parent, it is 0 at the rate 1. So 0 to basically it means from when we go to 0 to 1, do we have an answer? Yes. So now we have an answer for 0 at the rate 1, 0 at the rate 1, and it is, we have 1 comma 1, 1 comma 1. So now we again have moved back to the 0, and it will return 1 comma 1 as promised. So now what we have, now the sum was initially 0, the source was 0. So now the sum was equal to, initially it was what it was 0, and now count was 1. So according to this, we get 1 comma 1 over here. It is returned from the source equal to 1 to source equal to 0. Okay, back. So what we will do, we will add sum, we will add the first element to the sum, and we will add the second element, that is I equal to 1, to count. So okay, now sum was 0, so it became 1, and count was initially 1, so it became 2. We will add it 1 1. So okay, so now iterate second element. Second element of the array list associated with 0 is 2, and 2 is also not seen. So we will call the next. So we have now source equal to 2, source will be equal to 2, and now parent will be again 0, since it is called from 0th index node. So again we have the same thing. We'll add first it to the scene, so that we can, okay, we have seen it. Then what we have is key is at the rate 0 at the rate 2. Okay, 0 at the rate 2, and then again we will see the list associated with 0 with 2, sorry. So the list associated with 2 has 0 comma 3. So the first element is 0, and it is already seen, so we won't call it any DFS for that. Next element we have a 3. 3 is not yet called. Okay, so 3 is basically not yet called for not in the scene matrix. So now this will again call a new DFS with source is equal to 3, source will become 3, and parent will become 2, and the key will be the parent, that is 2 at the rate 3. Okay, so this will be the key. And also one thing, just we have to again of course initialize count and sum. So count was here was 1 and sum was 0. Okay, so we had this, we have initialized this. So now next we will get the list associated with 3. Now the list associated with 3 simply has a 2, and as we can see 2 is already there. So 2 is already there in the scene. So, and we also had to add the 3 to the scene, so it won't perform any further DFS since 2 is already seen. And so what it will, so at the end again we will do sum is equal to sum plus count, so sum will become 1. We will have for 2 at the rate 3, we will have simply have 1 comma 1, and this will be returned back to the source equal to 2, so it will be returned back over here. So again sum and count will be incremented by 1, so this will be 2 and this will be 1. So again we will forgot to store in a DP, we will store 2 for 2 at the rate 3, we have a 1 comma 1, we have a 1 comma 1, and now for here also we got the answer. But again one more thing, at the end we have to do this. So sum will be equal to sum plus count. So now sum was 1 and 2 count was 2, so sum became sum plus count, that is 1 plus 2, that is 3. So it became 3, 2 comma 3. So we will store this sum comma count, that is we will store for 0 at the rate 2, which was our key over for source equal to 2, 0 at the rate 2, we will have sum comma count. So 3 comma 2, 3 comma 2 will be stored over here. Okay, 3 comma 2 will be stored over here. and this will be returned back, that is to 0, that is 2 comma 3 comma 2 will be returned back. So now sum will be added to sum, and the count will be added to the count. So sum will be added to the sum, that is it will become a 4, and count will be added to count, so it will become a 4 again. So it became a 4. So now what we will do, so at the end, since we have iterated through all the elements of the source equal to 0 associated list, we will add sum equal to sum plus count. So we will get sum will be equal to sum plus count, so 4 plus 4, that is 8. Okay, and count will remain as 4. So for minus 1 at the rate 2, for in the DP, for minus 1 at the rate 2, we will at the rate 0, sorry, minus 1 at the rate 0, we will store a sum comma count, that is 8 comma 4. So 8 comma 4 will be stored over here. Okay, and at the end what we will do is that we will, since we don't have any other elements, we have seen all the elements, and so we will return that to the sum, that is answer. So 8 comma 4 will be returned over here, sum comma count. So 8 comma 4 will be returned over here, and here what do we do, answer I will store current 0, that is 0th element minus first element. So 8 minus 4, 4 will be stored as the answer, that is sum of the distances between node 0 and all the element is 4. No, just look at it. So distance between 0 and 1 is 1, distance between 0 and 2 is 1, distance between 0 and 3 is 2, because 0 2 and 2 3, so 2. So 1 plus 1 plus 2 is 4. So we got for 0th index 4. Now we have to just go through all the elements and do the same thing again and again. So let me do it. Okay, so now for I equal to 1, for I equal to 1, again I will call with source equal to, now see, we have a new scene. So the previous changes we do not alter the scene matrix, this as this is a new one. So now what, for first of all I will have for source equal to 1, source now will be equal to 1, and now parent will be again minus 1 for current one, since it is a new one. So it will be called freshly from the main function to the new one, DFS matrix, DFS function. So now we will follow the same procedure. First we will add 1 to it, then we will again create a key with parent at the rate minus 1 at the rate 1. So now next one is sum. Sum will be equal to 0 and count will be equal to 1. For now count will be equal to 1, and then again I will take the list associated with 1 now, because source is 1 over here. So the list associated with 1 has 0, and 0 is not yet seen. So now let's call, so now what we will do is we will call from source 1 source 0, and now parent will be 1. So now source will be equal to 0, 0, and now parent will be equal to 1. So as you can see, there is no a single parent, or just by looking at the tree we can tell the what is a parent. We have to make each and every node as the parent, and we have to check it. So okay, so what I will do is that I've yes, so I've made it. So again the new node or the key will be 1 at the rate 0, and now so again sum and count will be as it is. So we will also add 0 to the scene. Now now the list associated with 0, so it has 1 and 2. Now 1 is already seen, so now the next one is 2. So 2 we will again call 2 from here. Okay, so as you can see, I have a key as 0 added 2, since it was called from 0 and the source is 2. So 0 added 2. Now the DP comes into picture, because we already have 0 added 2, and for that we have sum comma count pair as 3 comma 2. So as per this code, we will simply return over here, as you can see, we will simply return that key, that element. So 3 comma 2 again without any further DFS call. Now 3 comma 2 will be returned over here. So 3 comma 2 is returned, and the same procedure as the previous one will take in place. So again we will have source will be sum will be added to the child sum, that is sum will become 3 and count will become 1 plus 2, that is 3. Then now for now 0, we have visited 1, we have visited 2, and also we forgot to add this 2 over here. So now nothing else is can be visited through 0. So now now what we will do is that we will move back. No, before that, what we do is that we add sum plus equal to count. So now sum will be equal to sum plus count. So sum will become 6 and count will remain as 3. So we will return 6 comma 3, and also before that we will add this to dp. So 1 at the rate 0. So 1 at the rate 0 we will add over to dp, and it will be equal to sum comma count, that is 6 comma 3. Okay, 6 comma 3 will be added and it will be returned back. So 6 comma 3 is returned. Okay, so now now what we have is that sum will become 0 plus 6 and count will become 1 plus 3, that is 4. And then the next one, that is now source was 1. So now we have visited all the elements from source equal to 1, that is only 0 was available, and from 0 we get this answer. So now no further thing will happen, and again we will do sum plus equal to count. Sum will become 10 and the count will be equal to 4. So 10 comma 4 will be stored for minus 1 at the rate. So as you can see, for minus 1 at the rate, we had the key as minus 1 at the rate 1. No, for minus 1 at the rate 1 we store 10 comma 4. So now this is the end. So it will return back. So it will return this 10 comma 4 back. Sorry, actually it will return this back to I equal to 1. So now what I equal to 1 will store over here? Current of 0. As you can see here, this part, this above part, current 0, that is 10 minus 4, that is 6. 6 will be stored over here. And if you check for I equal to 1, the distance between 1 and 0 is 1. Distance between 1 and 2 is 2. And distance between 1 and 3 is 3. Okay, so now what is 1 plus 2 plus 3? That is 6. So now 6, as you can see, is the answer. And you also got to know how this dp, how this dp came into picture. So now the same thing will be repeat for I equal to 2 and I equal to 3, and at the end we will return this answer to the function, from the main function to the and we will return it. So this was basically how the code works. I tried to explain you, it was a bit longer explanation. So I tried to explain you not all the things, but yes, some of things, because it is quite a long video. So now let's submit it. So as you can see, the code is getting submitted. So this was the entire code which I explained to you just now. So it was a bit different approach than the using a post order and pre-order traversal. That was also a method, but I found this one as a bit simpler one. So I hope you liked the video. It was a bit longer video, and thank you for being with me, and do like and subscribe my channel if you liked it. Thank you very much.